Hey guys, welcome back. Today we will be seeing on how to make a RC car using NRF24L01. In this video we will be seeing about the motor driver L298N module and the joystick module, which I have also used in my Omni wheel bot. A RC car contains two main parts, that is a receiver and a transmitter. Here the bot acts as a receiver and the joystick controller acts as a transmitter. So we will be seeing the circuit connection and code for both. Before going into the coding part, we need to understand how the bot moves. For forward and backward motion, both the wheel have to move in same speed in same direction. But for left turn, the left side wheel should move backward and right side wheel should move forward. And for turning right, it should be reverse of the left turn motion. To move the wheels like that, we need to have complete control over the motor. For that, we must control its speed and rotation direction. This can be achieved using a motor driver. With the help of L298N, we can control the direction and speed of the motor. L298N has a H-bridge circuit which helps us to change the direction without changing the polarity of the supply voltage externally. Here, IN1, IN2, IN3 and IN4 are the direction control pins. Speed can be controlled with the enable pins present in the circuit. When you give a 5 volt to this pin, it will rotate at full speed, and when 0 volt is given, the motor stops. And with the help of PWM signal, we can control the speed of the motor. Speed can be varied by varying its input voltage, but it is impossible to do it in a moving bot. That's why we use a PWM technique in which we send a series of on-off pulses called duty cycle to control the average input voltage. So higher duty cycle means higher speed and lower duty cycle means lower speed. By changing the polarity of the supply voltage externally, we can change the direction of the rotation. But again, this is impossible in a moving bot. So we use a H-bridge circuit made of 4 switches with the motor at the center to change the voltage polarity internally. This is done by closing 2 particular switches at the same time. When input 1 is high, the motor rotates forward. And when input 2 is high, the motor rotates backward. This is the internal block diagram of L298N IC. When IN1 is high and IN2 is low, the power flow direction is shown by the red arrow mark. So for making the bot, you require 2 DC motor, a L298N motor driver, a 9 volt battery, Arduino Uno and a NRF24L01 module. This is the pinout diagram of the NRF module. The NRF has a range of 100 meters and we can have 125 independent modules working in one place. A single NRF module can communicate with 6 other NRF modules at the same time. I have given a link in the description in which you can find the library required for the NRF module and how to use them. This is the joystick module. Its working is simple. It has 2 potentiometers attached to it, whose output can be measured by connecting VRX and VRY to analog pins in Arduino. And it also has a switch which can be connected to a digital pin in Arduino. This is the joystick controller. I have used the 9 volt battery as a power source. And this is the joystick module. This one is the NRF module and I have used the Arduino Nano. When I switch it on, the LED in Arduino Nano starts to blink fast, which indicates that it's transmitting the data. This is the circuit connection of the joystick controller. I have given a link in the description for the transmitter and receiver code, but before using those codes, you need to install the libraries for the NRF module.